Hey guys, so welcome back. In this video, we'll be trying to solve the problem of the day of 4th November on Geeks for Geeks, that is frog jump. Alright, so you will be given an array called height. Now, height will contain some values inside of it. Basically, you have to find out the minimum cost to jump from the starting node or the starting element till the last element. Alright, now how we uh, find out the cost is that it is the difference of the place from where you start and the place where you end. Okay, so you're allowed to jump 2 steps or 1 step. Now, say for example, you're jumping 1 step. Say for example, you're jumping from 20 to 30, for example. Cost will be the absolute value of 20 minus 30, which is 10. All right. Say for example, you're jumping 2 steps from 20. Your landing node is 40. So your cost will be the difference between 20 and 40, which is 20. All right. So you have to basically find the minimum cost to jump from the starting node till the ending node. All right. So let's see how we can solve this. Now you can solve this in either two ways. You can either do the recursive approach. I tried doing the recursive approach actually, but I got the runtime limit exceeded error. All right. The other way of doing it is the dynamic programming approach. All right. So I'll be explaining how the DP approach works. Okay, I'll be taking the first example for this. Now, as you guys know, every DP approach, it contains a DP array. Okay, I'll be explaining what this is in case you guys are not familiar with it. All right. Always remember that your DP array will be the same length as your input array, or like in this case, the heights array. So I'll be having 4 spaces instead of this. All right. So I'll basically be explaining what this DP array is and what each index stands for. All right. DP array, right? Every single position within the array stands for the minimum cost to jump from that particular index till the last element. Okay, I'll be repeating it again. It will be containing the minimum cost to jump from that position till the last element. So I'll be explaining what that means right now. All right. Now we'll be filling the DP array from the end. Okay. Now our last element is 20. What is the minimum cost to jump from 20 to the last element? 0, right? Because 20 is the last element. You have no cost. All right. Let's fill in the second last element. You have 40. From 40, as I said, you can either make a jump of 2 steps or 1 step. Here a 2 step jump is not possible because you'll be overshooting the array, right? So only a 1 step jump is allowed. So what is the minimum cost to go from 40 till the last element? Absolute value of 40 minus 20, so 20 will be your answer. All right, as simple as that. Now, this is where the fun part begins, or I should say the more challenging part. It's still quite easy. We have to fill in the suitable values from the third last element onwards till the first element. All right, now how do we fill it for this? Now, I'll be taking 30 now, right? Now 30 is the next element. Remember, from 30, you can either make a jump of 2 steps or 1 step. So we'll be calculating the minimum number of costs required by calculating the cost required for 2 steps and 1 step. So like say for example, the cost required while taking 1 step is 5 and the cost required if you take 2 steps is 7. We'll of course take only 1 step because that has the minimum cost, right? All right. So we'll be finding out the cost if you take 1 step and 2 steps. So I'll just be doing 1 here and 2 here. Okay. Now, say for example, you take a 1 step, okay? From 30, you're jumping to 40. What will your cost be now? Absolute value of 30 minus 40, 10 will be your answer. But wait, this is not your cost to jump till the end. This is the cost to jump till the third element. From the third element, you have to jump till the end. And that is what we have right here. Like this is why your DP array is useful. Because you memorize the data you know and you can use it later on. Because we have this stored, we know that the minimum cost to jump from the third element till the last element is 20. Right. So I can just add 20 along with this, which brings my final answer to 30. All right. Now, that is if I take 1 step. Let's say, for example, I take 2 steps. So from 30, I directly jump to 20. How much will it be? Absolute value of 30 minus 20, 10 is my answer. Plus the minimum cost to jump from my fourth node till the last node. Since they both are same, it is plus 0. So 10 will be my answer here. So now we have two possible paths. This is one path, this is another path. But which path will you choose? The path with the lowest cost. So this is the answer that you need. So 10, you will add it over here. Hopefully you guys understood, right? It's pretty basic. Now let's go forward and think about the first element. Now from 20, again, you can do one step, you can take one step, or you can take 2 steps. Say for example, you take one step. From 20, you go to 30. What is your initial cost? Absolute difference, 20 minus 30, 10 is your answer. Plus the minimum cost to go from the second element till the last element, which we have stored in our DP array already, 10 is the cost. So we'll do plus 10. The total cost comes out to be 20. Okay, fine. Now like that's if you take one step. Say for example, you take 2 steps. From 20, you directly jump to 40. What will your cost be initially? Absolute value of 20 minus 40. 20 is what your answer will be. Plus the minimum cost to jump from the third element till the last element, which again is 20. That makes your final cost to 20 plus 20, which is equal to 40. We have two possible paths, right? Which path do we choose? We choose the path with the with the lowest number. So 20 is what you will choose. So we can add 20 over here. Now what should you output? You should output the lowest cost to jump from the starting node till the ending node, and you have that with you already. This is the answer, right? So you just output 20. So that's how you solve this problem. Now let's see how we can code this out. Okay, so let's code this out. The first thing is you'll be having n as the length of your height array. I'll just make things easier. Now, if n is equal to 1, we can just return 0. Because if your array's length is 1, you're already at the beginning and last element, so it makes no sense. Right. Now we create our DP array, right? DP of 0 into n. Then you put the last element to be equal to 0, as we discussed earlier. DP of the second last element will be the absolute value of the last and second last element. So height of n minus 2 minus height of n minus 1. As simple as that, right? Now we make a for loop to go from the third element, or the third last element rather, to the first element. Right. Now we have to calculate the cost. Cost, if you take only one step, which will be the absolute value of height of I minus height of I plus 1, right? Plus the cost from, plus the minimum cost to jump from your landing node till the last node, which will be dp of I plus 1. Now, cost if you take 2 steps, absolute of height of I, same thing, minus height of I plus 2 in this case, because you're doing 2 steps, right? Let's just remove the space here. All right. Plus dp of I plus 2, because that will be a landing node in this case. All right. At the end, just set dp of I to be the minimum value of 1 and 2. That's what you need, right? And just return dp 0. Basically, the first element as the output. Let's see if this works. Okay, there's n minus 3, my bad. Error, most probably. Yeah. And there you go, it works. Let's submit. There you go, that's how you solve this problem. If you have any doubts, do let me know in the comment section down below. And that's it for this video. I'll see you in the next one. Goodbye.